gentlemen, my name is Dr. John Belkowitz, and we're here to talk to you today about colloidal silica, this stuff right here. It's a liquid product that has been used in the industry for well over a decade now to make concrete stronger and last longer. And if we're lucky, we'll also be talking about the hand penetrometer. No, we're not. We're going to talk about this, I promise you. I'm doing this for them, Patchouli. Get into so much trouble. So we're opening with, the purpose of this presentation today is to show how we come up with a surface area for a Class F fly ash that we normally use in concrete to make it stronger and last longer, and the equivalent amount of surface area of colloidal silica based on the size, the silica purity, and the surface area of both. The second thing that we're doing is calculating that percentage into a dry weight, but more importantly, this is not a dry material, it's a liquid material. So what to pour into the concrete mix. Did I do good?
Good.
Awesome. Okay, so let's get into the math. Class F fly ash is something that's been used in the concrete industry for many decades to reduce the porosity, increase the development of calcium silicate hydrates, and it's the silica in the fly ash that consumes some of the calcium hydroxide to create more of the backbone of concrete strength, the calcium silicate hydrate. So here is our Class F fly ash. This is something that we got here in Colorado. Has a surface area of 0.84 meters per gram and a silica purity of around 36%, and we were using about 20% replacement in our concrete mix. So this is our colloidal silica, and we were using a very specific type of colloidal silica, 3 to 5 nanometers in range of particle size with a surface area of 500 meters squared per gram. The replacement percentage, which is what we're going to figure out today here in a second, it's so exciting, was 0.012% compared to the fly ash at 20%. We have a silica purity of 99.8%, a specific gravity of 1.10 grams per cubic centimeter, and a solid content of 15%. Our concrete mix had a total cement content of 650 pounds per cubic yard. So here are our calculations. In the first piece of the calculation, sounds funny, sound like a pirate. First part of our calculations is to determine not only the weight of Class F fly ash that was being brought to the mix, but the surface area, or the pozzolanic surface area, that was being brought to the mix by our Class F fly ash. So we have a weight replacement of 20% times 650 pounds per cubic yard, which comes out to 130 pounds per cubic yard. Fairly easy calculation. And this is where we start getting into the fun stuff, which is really just unit conversion. So 130 pounds per cubic yard, we convert that to grams by multiplying it by 453.6 grams per pound, and then multiply that total grams now by our silica purity, which was 36%, and then we finally multiply it by our silica surface area, which was 0.84 meters squared per gram, to get a total of 1.78 times 10 to the 4th meters squared per cubic yard. And if that sounds confusing, it was designed to be confusing. No. What we're trying to identify is the amount of surface area that our fly ash brings, or instantaneous pozzolanic or silica surface area that our fly ash brings to the concrete mix. So what we do is we take that 1.78 times 10 to the 4th meters squared per cubic yard of concrete, and we use that to back calculate how much colloidal silica we will need. Now, if you haven't noticed it already, Class F fly ash has a very low purity and a very low silica surface area. Colloidal silica has a very high purity and an extremely high surface area. So that being said, we should need a lot less of our colloidal silica to get the equivalent amount of our Class F fly ash. So we're taking our 1.78 times 10 to the 4th meters squared per cubic yard, and we're dividing it by that same concept, that silica surface area brought by our nanosilica, or colloidal silica dispersion. So 650 pounds per cubic yard times 453.6 grams per pound times our silica surface area, and also times our surface area, or our silica purity, and then multiply that by our silica surface area that our colloidal silica brings, to give us 0.012%. So to get the same surface area that you would get from 20% fly ash, you would need 0.012% of this colloidal silica. Now here's the catch. We don't sell our nanosilica particles in a universal dispersion in a dry form. They're sold in a liquid form. So we have to figure out what that dry form looks like in a liquid form, because that's how we get into the back of the truck. So first we determine our dry colloidal silica weight. We multiply 650 pounds per cubic yard by 0.012% to give us 0.08 pounds per cubic yard. And then we convert that to a fluid ounces per cubic yard. We take that 0.08 pounds per cubic yard, multiply it by grams per pound, at 453.6. And again, that's just a unit conversion. And then divide that by our total solids content. We divide that one more time by our grams per cubic centimeter to convert that into a fluid. Now we have milliliters, and we convert those milliliters to fluid ounces by dividing it by 29.57 milliliters per fluid ounce to get us 7.3 fluid ounces per cubic yard. So if you wanted to use 0.012% colloidal silica in your concrete mix design, you would need, for this specific dispersion, you would need 7.3 fluid ounces per cubic yard. So ultimately, the objective of this talk was twofold. One, to show you how we got the equivalent surface area between fly ash and colloidal silica, and the second thing was to show you how to take that dry percentage and convert it into a liquid content to pour it into the back of the truck to make that concrete stronger and last longer. And I hope you had a great time today. I know I did. Really wanted to talk about the handheld penetrometer, but we'll do that next time. If you have any questions, any comments, any concrete concerns, shoot us a comment, a direct message. Hope you had a great day. Saving the world with all the concrete in it. Go concrete.
Beat asphalt.
That was with me.